Welcome to Math 107. This is the video for the Lesson 10 class activities. All right, so I'm supposed to determine whether each of the following relations is a function and then find the domain and range. Okay, so the definition of a function is that each x value can be associated with only one y value. So Phoebe, is Phoebe associated with more than one y? Nope, she's 5 feet 5 inches. Amy, is she associated with more than one y? No, she is just 5 feet 5 inches. And Katie, is she associated with more than one y value? Nope, she's 3 feet 1 inch. So yes, this is a function. The domain is Phoebe, Amy, and Katie. We list these things in curly brackets because it's a set. And then the range is the heights of 5 feet 5 inches and 3 feet 1 inch. All right, another one where we have a picture. Is it a function? So you have to ask yourself, is there an x that gets mapped to more than one y? So 0 gets mapped to 7 and only 7. That's okay. 3 gets mapped to 7 and only 7. -2 gets mapped only to 7. 6 gets mapped only to 7. So yes, this is okay. This is a function. Okay. Its domain is the set on the left, 0, 3, -2, 6. And its range is the set on the right, which is just 7. All right, we're going to look at this in a slightly different way with some ordered pairs. So is this a function? So I'm asking myself, is there any x value that's associated with more than one y value? So -1, it's only associated with 2. There's no other place where it has a different y value. 0 is only ever associated with 2. There's not 0 something else later on. 1 only associated with 5, 2 only associated with 3, and 3 only associated with 2. So yes, this is a function. Its domain is the set of first numbers in each ordered pair, so -1, 0, 1, 2, and 3. And its range is the set of second elements in each ordered pair. So it's going to be 2, then there's another 2, then there's a 5, then there's a 3, then there's another 2, and I'm not going to write it because I don't need to repeat. All right, here's another set of ordered pairs. I need to find out, is there any x value that's associated with more than one y value? So I'm going to key in on this point and this point. So I have an x value of 3 that's associated with 2 different y values. 3 is associated with 7, and 3 is also associated with -4. So this is not a function. Right? Each x can be paired with only one y. It's not a function, but it does still have a domain and range. The domain is still the set of all x coordinates here. So I've got 3, -3, -4, and 1. And the range is 7, 2, 5, 4, and -4. All right, let's look at E here. We have another picture version of a relation. So I need to ask myself, is there any x value, any value on the left that's associated with 2 different y values, 2 different values on the right? And yes, 1 is getting mapped to 8 and to 11. That is not allowed for it to be a function. So this is not a function because 1 is paired with 8 and 11. It does have a domain and a range, 1, 5, and 12 for the domain. And the range would be 8, 11, and 4. All right, one more set of ordered pairs. So I want to check if there's any x value that's paired with more than one y. Okay, so I have an x value that repeats. I've got a 1 and a 1, but in both cases it gets paired with 2. So this doesn't violate the rules of being a function. 1 gets paired with 2, 1 gets paired with 2 again. That's fine. 1 is only paired with a single y value of 2. So yes, this is a function. Its domain is the set of all x coordinates, 1, 2, and 3. And its range is the set of all y coordinates, 2, 6, another 2, I'm not going to write it again, and 4. At a coffee shop, the board lists types of coffees and their prices. Is the price a function of the type of coffee? Is the type of coffee a function of the price? Okay, so let's see. Is the price a function of the type of coffee? So coffee would be input. The thing that you order is the input. Price is the output. For it to be a function, each possible coffee order can be paired with only one price. I would hope that's the case. I hope that when I go into my favorite coffee shop and I order a latte, that the price is always the same, right? That the price is always $3, right? And not sometimes 5 and sometimes 3 and sometimes 7, right? So like if I'm putting in one ordered pair, for example, might be latte, comma, $3, right? Or we might have just a small coffee, $2, right? So each X value, coffee that you order, can only be paired with one price. So, so price is a function of the coffee type. Right? But is your order a function of price? If I said, oh, I went to my favorite coffee shop and I spent $5, do you automatically know what I ordered? I suppose it depends on the shop, but likely not, right? Likely not. I could have spent $5 on an iced coffee or a latte. Either one could cost me $5, right? So coffee order is not a function of price, right? Because any price could be paired with two different orders, more than one order. Okay, next one. Which of the tables below defines a function? So table 1, I have inputs -2, 0, 1, and 2. And none of those inputs ever gets paired with more than one output. So this one is a function. Table 2, input of -2, -1, 1, and 2. Each one of these never gets paired with more than one y, right? -2 always goes with 5, -1 always goes with 5. This one's good, it's a function. And then table 3, I've got -4 gets paired with 2, and then -4 gets paired with 4, right? So I have an x value of -4 that's getting paired with more than one y value. So this one is not a function. Okay, so when we're dealing with functions and relations, we can think of them as ordered pairs, which we can plot in a graph. Our corresponding sets are real numbers, then you can use a graph of the ordered pairs to determine if we have a relation or a function. The set of all x coordinates represents the domain of the relation. The set of all y's represents the range. Use the domain and range to determine if it's a function. Okay, so the domain here would be all the x coordinates. So I've got -4, and then I'm working left to right here. The next point has an x coordinate of -2, and then the next one has an x coordinate of 0. And then these 2 points have the same x coordinate of 1, right? They have the same x coordinate of 1, but different y coordinates. One's 4 and one's -2. So that's not a function. But I can list its range. Those are all the possible y coordinates. So let's see. I'm going to go top to bottom here. So the biggest one's a 5. Then we have a 4. Then we have a 2. Then a 0. And then a -2. So there is a visual test that we could use at a glance to determine if a graph represents a function. And it's the fact that these 2 points, they have the same x value, but different y values, and that means that they lie on the same vertical line. So we have this test called the vertical line test, which is number 6 here, the vertical line test. It says that if any vertical line intersects a graph in more than one point, the graph does not represent a function. So this first one is a function. We can sweep a vertical line through it from left to right, and it will never touch in more than one spot. But this next picture is not a function, because as we sweep a vertical line from left to right, there are places where it hits in more than one point. Okay, so that one's not a function. So to use the vertical line test, in A, I'm just going to draw several vertical lines, never hitting more than once. That one's good, that's a function. And then B, drawing several vertical lines, seems to be fine. I have a little bit of a question right here, right? Is that hitting in more than one spot? And the answer is no, because this point has an open circle right here, which means that that point is not included on the graph. And this one is closed, so it's actually only hitting the closed point there. So that is a function. And then C very clearly fails the vertical line test, not a function. All right, so coming back to this baseball example, the variable x is called the independent variable because it can be assigned any value from the domain. And the domain in this situation is non-negative time. Okay, non-negative time. The variable y is called the dependent variable because its value depends on x. And the value of y is found after selecting a value for the independent variable x. Okay, so y depends on x, so we call it the dependent variable. The height of the baseball depends on how long it's been since you threw it. We can also represent that table of values with an algebraic function. F of x equals negative 16x squared plus 80x plus 3. And the domain for this one would be positive x greater than or equal to 0, such that x is an element of the real numbers. All right, so I want to use the equation, not the table, to find f of 2. So the table, I know, we did this earlier, tells me that 2 should have a height of 99. After 2 seconds, the height should be 99. But f of 2 using the equation, again, that 2 is representing an x. So I'm going to go to my equation. I'm going to replace all the x's with the 2. So this is negative 16 times 2 squared plus 80 times 2 plus 3. All right, 2 squared is 4 times 16 is 64, so that's negative 64. 80 times 2 is 160 plus 3. And that comes out to 99, just as the table says. So now I want to use the equation, not the table, to solve f of x equals 99. So I'm solving for x, and I want the output to be 99. I want the y to be 99. So I want 99 equal to negative 16x squared plus 80x plus 3. Now I already know that the answer should be 2, right? Because when I put a 2 in, I get 99. So if I have an output of 99, the input that creates it should be 2. But we're going to solve it just for fun, practice. All right, so this is a quadratic, so I need to make one side 0. So I'm going to subtract 99 from both sides. I have negative 16x squared plus 80x, and 3 minus 99 is minus 96. And then you could factor or quadratic formula. I'm going to use a quadratic formula because figuring out that factoring is going to be a pain. So I'm going to say x is negative b plus or minus the square root of b squared. That's 6,400. B squared minus 4 times a times C all over 2 times A. Okay, so this simplifies to negative 80 plus or minus the square root of 256 all over negative 32. And that would be negative 80 plus or minus 16 all over negative 32. So there's going to be two possible answers there, one for the plus and one for the minus. So let's see, negative 80 plus 16 divided by negative 32 is 2. And then I'm going to do the minus. So I've got negative 80 minus 16 divided by negative 32 is 3. So that's interesting. I was expecting the answer to be 2, but I ended up getting 2 and 3, right, as my x values that would give an output of 99. Let's look at the table here. Well, yeah, it looks like 3 also, the baseball also has a height of 99. So it must have hit a maximum height somewhere between 2 and 3 seconds, and now it's coming back down. The graph of the function can be found by plotting various ordered pairs x, y that are solutions to the equation f of x is negative 16x squared plus 80x plus 3. The points that were in the table are all along that parabola. So use the graph to evaluate f of 4. So I find 4. 4 is in the parentheses, which means it's an x. So I find 4 along the x-axis. And then I go up to the graph, and I see that the y value is 67. All right, here's just another picture of the graph. I want to use the graph to find all solutions to f of x equals 67. So now they're giving me the y, and I want to find x's that have an output of 67. So here's 67 along the y-axis. Okay. There are 2 points on the graph that have a y-coordinate of 67, and their x-coordinates are 1 and 4. So 1 and 4 are the solutions to that equation. And then I want to use that equation to determine how long it will take for the baseball to hit the ground. Well, when a baseball hits the ground, it is 0 feet above the ground. I'm trying to solve for how long, which means I'm solving for x, which is time. So how long until my y-coordinate is 0? And again, I could try to factor it, or I could try to quadratic formula it, and I think I'll do the quadratic formula. So x is negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. All right, so that becomes negative 80 plus or minus the square root of 6,592 all over negative 32, which is negative 80 plus or minus the square root that number. It's about 81.2 all over negative 32. All right, so put this in the calculator. I have negative 80 minus 81.2 divided by negative 32, and that's about 5.0375 seconds. And then I have another solution that's going to be the plus. Negative 80 plus 81.2, and then divide that by negative 32, and that's negative 0.0375 seconds. But we talked about the domain of this function being strictly positive values because this is time, and it's measuring time since you threw this baseball. And before you threw it, you have no idea what the baseball was doing. So we can't use negative time to determine the height of the baseball. So this baseball hits the ground after just over 5 seconds. Okay, so if I want to use interval notation to represent the domain of the function, right? The domain is a set of all times that you can use to describe the height of the baseball. We would say time 0 at the moment you throw it until it hits the ground, 5.0375, right? Because then once it hits the ground, that formula isn't going to apply anymore because it will tell you that the ball keeps falling, and it can't because the ground stopped it. And then interval notation to represent the range. Well, let's look at the graph. The range is the smallest y value to the biggest. But in this physical situation where we're measuring the height of a baseball, the lowest it can be is on the ground. So that would be 0 height off the ground. And then its highest point is 103 feet off the ground. So we've got 0 to 103. And it achieves both of those heights, so we include it with a square bracket. All right, so that does it for the lesson 10 class activities.